Alright, so what we're going to look in this chapter is that when we have a similar shape, it also affects, we can say that their area and their volume is similar. But the thing that when we're comparing, we have to be careful. The area and the volume, they go up by a different amount even to the length ratio. So what we're really going to remember that the scale factor, which we often call which is K, is the length ratio or the length factor, okay? So what we'll notice is that there is, say for example, if I drew a square here, so squares are easy to see, okay? So if I said that this square was, had a side length of 2 and this one had a side length of 4, so you're going to say, if we would say if we did the length ratio, so remember if we say new over original, we would say that the length ratio was 4 over 2, which is, we can say is 2. So the next square is 2 times larger than the next one. Now, if you thought about their area of these squares, so remember the area is like length squared, so 2 times 2. This one area would be 4 and this area would be 16. So if you compared their areas, if you have a look, if I did say area of the new over the area of the original, you'll see I would have 16 over 4, which ends up being 4. So which is actually K squared, because if you look up here, K was 2, if you square it, it's 4. So what the area becomes of a similar shape, the area is the K squared bigger. And if you did volume, so say I changed these to a little block like that, you would do, remember that the volume, say the volume of the new over the volume of the original. So remember the volume is 2 cubed for the first one, so that would be 8, and 4 cubed is 64. So if you do that, you see 8. So you can see that the volume is actually this length ratio, or K, cubed. So that's what we need to remember when we're going to compare, because they're going to ask us to compare. So we first find out what the length is, and then we're going to use it either squared if we want area, or we're going to use cube it if we want a volume. So best to just go and do some questions. So let's have a look here. So we've got these 2 triangles and they're similar, so they're going to tell you they're similar, and they've given you the base of the smaller triangle is 10 and it has an area of 40 centimeters squared, and then it has the base of the larger triangle is 25. So they're actually, these 2 values here are giving you the length ratio, or if you want the K. So if you say this is the new, this is original, we've got 25 over 10. So that's what I've done here. So 25 over 10, so 5 over 2. So this is how it's changed. So if I want to compare the areas, what I'm going to do is, it's like you use the K as your corresponding sort of side, but you're going to square it. So K squared. So you can just leave it like that, where you just leave it as a fraction and make sure you square the whole thing. Or you could say that K squared is like saying, if I square both those numbers, like 25 over 4. I've squared both numbers, equals x over 40. So you can see we are comparing the areas, because I want to know the area of the new one. So the area of the original is here, and this is the area of the new one, and I'm comparing it with K squared. So you can just pop that solve into your calculator like that, and we'll find the area. I might just pause. So we got x to equal 250 centimeters squared. So this triangle's area is 250 centimeters squared. Okay, so down here they said that these two cuboids are similar, and they give a height of 6 centimeters and then the height of the smaller one. So this allows me to set up the K thing. But they want me, and they tell me the volume of the bigger one, and they want me to find the volume of the smaller one. So all I'm going to do is, I know I've got to times it, the length by K cubed, okay? So we'll set it up like we did just above. So I'm going to do similar sides. So I've got 6 centimeters over 1.5. I'm just going to erase it out. So that is the length ratio, that's K. So if K equals 6 over 1.5, K cubed will be that, so power of 3. And that must equal the volume of the big one, which they gave me, over the volume of the small one, which I don't know. So I'll put that there. And we can simply just pop in solve, comma, x. So let's go do. Okay, so we found that x was I don't know, I'm going to do 2 decimal places, 1.88 centimeters cubed. That's the volume of the little one. Okay, so there we can do. Now, just to go over, if you were asked this actual scale factor in this, say that's the original and that's the new, be careful. You always have to, when you're asked for the scale factor, you do need to simplify your fraction. So you would say 6 over 1.5. Just type that into your calculator. So it's a scale factor of 4. So the object, the new object, the biggest volume cuboid, is actually in a size factor, is 4 times bigger. So its volume will actually be, if I cube that, because the big one's 120, this volume will be 64, 1 over 64 times smaller, because if we were going backwards. But you can just do it like this. Just be careful that the scale factor was actually 4 there. You'll have to simplify them when you're asked that. So let's just keep doing a few others to show. So you're going to see that they'll give you a length, and then so you can find what it is. And you just got to make sure when you set it up that you've got the right dimensions the right way. So I'm going to say, I'll say this is the original, this is the new. So I'm going to say, right, it's 60 over 12. That would be K, but they want me to find an area, so I'm going to square it. And I've got the 60 on the top, so its area will be on the top here, the new, over, I don't know what the area of the little one is, so I'll call that X. So once you do that, and then you can type in solve and comma X. So once again, you can just double check that these numbers are coming from the same shape. Yeah, and can you see they're both from the new object? Okay, and obviously down the bottom, that is still, they're both coming from the original. If you do that, then you'll be set that you're doing it right. Okay, so you could do that on your calculator. I'm not going to do everyone on the calculator. You can do that. Now this one, they told me its volume, the first pyramid is not, and so they told me in the wording that this one's volume is 48, and they want me to find the volume of this. Okay, so I have to compare something I have similar. So they gave me the same lengths here. So I'm going to call this this new. So I'm going to say 5 over 4. Now, because it's volume, I'm going to cube it, equals Now, the volume of the this one I don't know, so I might call it V in this instant, and I know the smaller one's volume is 48, and then I can pop that in and do, solve and comma V, okay, and then you would find it that way. All right, so the ratio, if just for an example, so you know, they might ask you what's the ratio. So say you enlarged it, say K equals 4, so it's 4 times larger. So what you have is you have a 1 to 4. It was started off at 1, it went to 4. If you ask for their area ratio, you're going to square that. So you're going to have 1 squared to 4 squared. So it'll actually be 1 to 16. The area is 16 times larger. If you have a volume ratio, you cube it. So the volume of the thing would be 1 cubed, which is 1, to 4 cubed, which is 64. So the volume is 64. Okay, sometimes they might give you some questions where they actually give you the this is when they give the volume ratio, and you need to go back, so if you want to go back, you do the cubic root. So say this example up here, if I do the cubic root of 1 and the cubic root of 64, we end up with a 1 to 4, and that ends up with back to my length ratio. So this is just a little way of saying if they give you this, how you can go back. Generally, we want to go back to length, or if you get the area and you want to go back to length, or if you're given the, obviously we've done this is what we've been doing. All right, so just got to go over these maps. So when you have a map and they give you a scale, they're actually giving you a, it is like a ratio, a similar figure. You think of the map as the smaller object and real life as the new big thing. So when you get a scale like this, when they write this on a map, what it means is if you have 1 centimeter on your map, it means that it equals 50,000 centimeters in real life. Okay, so if you have, I don't know, it depends how big your map is, but say you had 1 meter on the map, that's 50,000 meters on the in real life. Okay, so that's what this said. So on this map, the distance of 4 kilometers can be. So you can just set it up the same. So because they're using centimeters, we might change, we can just say 1 over 50,000. Now they're saying this is a real distance, okay? So that's the bigger bit. So I'm going to change this 4, because they want my answer in centimeters. I'll change the kilometers to centimeters, which would be you times by 1 kilometer has 1,000 meters, and then a meter has 100. So there you go. And I want to know what that equals, and we can do that on the calc. Okay, so we've done that. We did solve, comma x, and we got x to be 8 centimeters. Okay, if you had not changed this, if you just left, if you didn't have that and you did 4, what you would have got is x is it would have been 0.0000, like 8. So there would have been in kilometers, like, you know, 8, and that would have been annoying. So just change it to what you need there. All right, now let's have a look here. It says a block of land has an area of 4,000 square meters. This is represented as a block of land on the map as 10 centimeters squared. On the map, 1 centimeter would equal. So what they've actually given you is a area ratio. So what they're saying is, I'm going to say 10 centimeters squared over 4,000 meters squared. Yeah? So if you, first we simplify that fraction, that's going to be 1 over 400. So this is an area ratio. And when they talk about this thing here, 1 centimeter, that's a length ratio. So we want to go backwards. So when we go backwards, to find the length ratio, we're going to have to do the square root, like we saw that before. So we're going to do square root of that. So the square root of 1 over the square root of 400. So square root of 1 is 1. So because this was originally measured in, this was centimeters squared and this is meters, that's going to be 1 centimeter. And this will be meters, which is, the square root would be 20 meters. So 1 centimeter on the map is going to represent 20 meters in real life, okay? And think of it practically, that would make sense. Like, think of like if you were looking at a house plan, 1 centimeter, 20 meters, that's not too bad. Like, depending, if you're looking at a massive, you know, block of land, that's not too bad of a scale there. All right, so question 3, the cones are similar. So they're always going to tell you that these objects are similar, so you know you're going to be doing it. And it says it has B has a surface area of 342, and A has an area, sorry, that's centimeters squared, and A has a surface area of 38 centimeters squared. If the perpendicular height of B is 12 centimeters, so they told you what 12 is, then the perpendicular height of H is. So they want a length, so what we're after is a length. So we need the length ratio, but they've given me an area. So they've actually given me an area ratio. So if I do, if I compare the areas, we've got 342 over 38, okay? And what we're going to do is, if we were going back to find the length ratio, we would do the square root. You have to simplify it first. So let's simplify that first. So this ends up being 9 over 1, okay? So the length ratio would be the square root, because if you go backwards, you do the square. So square root of 9 over 1, okay? And that would equal our heights, our corresponding heights, because that would be a length ratio. So I could say that equals 12 over H, because I don't know what the smaller one is. So then you'll end up with 3 over 1 equals 12 over H, and you can solve. You can solve at any stage. You could have solved up there too, up here. But comma H, and we'll see that H equals 4 centimeters. Okay, so we've got that one. I'm not going to do this question 9. I'll do it with you after, because if it's last year's question, 9th question, it's going to be very hard. Well, not hard, but you need to practice this before.